Hello everyone, welcome to the video lecture series on 8051 microcontroller. So let us look deeper into the features of 8051 microcontroller, its architecture, its addressing modes and various type of timers. So let us get deeper into 8051 microcontroller. So here are the contents which we are going to deep dive into in the upcoming series. So first is the introduction to 8051 and 8051 architecture, its addressing modes and timers. So coming to the introduction of 8051 architecture, it is an example for CISC processor. So it is based on the Harvard architecture and its collection of both 8 and 16-bit registers and 8-bit memory locations. And external memory can also be interfaced with this 8051 microcontrollers. So coming to the pin description or the pin diagram, you can see 8051 is generally a 40-pin microcontroller. So starting from pin 1 to pin 8, it is port 1. So the port 1 is given as port 1.0, port 1.1, port 1.2, etc. up to port 1.7. So pin number 9 is just to reset. And again from pin 10 to pin 17, it is for port 3. That is port 3 again carries 8 pins, which is from P 3.0 to P 3.7. So from pin 10 to pin 17. Next, pin 18 and 19, as you can see, it is for XTAL2 and XTAL1. And next is the ground pin at pin number 20. And coming to pin number 21 to pin number 28, it is for port 2. Again, the port 2 carries 8 pins starting from P 2.0 to P 2.7, as it is clearly shown in the pin diagram. And next is PSEN at pin number 29 and pin number 30 is ALE and pin number 31 is EA and pin number 32 up to pin number 39 is for port 0 where port 0 is from port 0.0 to port 0.7. Again, this consists of 8 pins and pin number 40 is for VCC. Here XTAL1, XTAL2, PSEN bar and ALE and again pin number 31 and pin number 30 which is being multiplexed with PROG, etc. All these things which we'll be discussing in the forthcoming series. So as I said, so pin number VCC pin 40. This generally provides the supply voltage to the chip and the voltage source is 5 volts. So the ground pin 20 is, as you know, it is generally for the ground and XTAL1 and XTAL2, as I said. So pin numbers 19 and 18, it is generally used to provide the external clock. And coming to reset pin at pin number 9, it is an input pin and it is active high, normally low. So upon applying a high pulse to the RST or the reset pin, the microcontroller will reset and all its value will be in the registers will be lost. So EA, that is external access in pin number 31, is the pin which is generally connected to the ground to indicate the code is stored externally. And for 8051, EA pin is connected to VCC. So the slash sign represents the bar here, which generally means the active low. And PSEN, it is the program store enable at pin number 21. This is the output pin and it is connected to the output enable pin of the ROM. And coming to pin number 30, which is ALE pin, that is address latch enable. It is the output pin and it is active high. As the slash sign is not given or the bar sign is not given, it means that it is active high. And 8051 port 0 provides both address as well as data. The ALE pin is used for demultiplexing the address and the data by connecting to the ground pin of the latch. So the input output pins, the 4 ports PO, P1, P2 and P3, each port uses 8 pins. So all input output pins are bidirectional. So this is the generalized block diagram which you can see here. And we know that for the block diagram, you can see all these pins and the registers which are being mentioned about in the earlier section. So you can also see that there are interrupt control, the registers and the RAM, ROM, the timers, the serial ports, transmission and the distribution port, the input output port, the bus control as well as the oscillators, CPU and the interrupt control. So about all these we'll discuss in the upcoming sessions. Thank you.